Hello everyone, I am Shaugi. Welcome to my channel Training Center Shaugi. Now I will show you something about brushless generator self-excitation. Alright, just go to the point. This is the cutaway view and here is the component. We have coupling. This part is directly connected to the engine's flywheel. Where is flywheel? It is here in the rear side of engine, and this is coupling. Yeah, same with this. It will connected to the engine. Why it must be connected? Because to receive the power, rotation power or rotation force from engine, so that the rotor can rotate like this. Then we have adapter. This is the part of generator body which is directly connected to flywheel housing. Okay, if the coupling we have here connected to the flywheel, adapter here in body connected to engine body, of course here flywheel housing. What is the function? The function is to help starter and rudder in line to engine. Next we have cooling fan. It flows air from rear side here to the side front of generator body. The function is to dissipate the heat that produced in winding. It brings the heat. This flow of air bring heat inside the generator, go to the outside. Next we have main rudder. This main rudder is the winding that is function to convert DC electric supply to magnetic field, from DC electric to magnetic field. So it means that this coil is field coil. The DC supply is come from rotating rectifier here. This magnetic field is needed in process of generating electricity. Yeah, as we can see here, there is formula RPM equal 120 times frequency divided by number of pole. So if we want the frequency is 50 Hertz in my country, of course, so we need 1500 RPM if we have 4 poles magnet in rotor. If you have different system and different requirement, please use this formula. Okay, main rotor has two functions. If I say, first is magnetic field generation, of course, from DC supply to magnetic field. We know that every conductor which has current in it will generate magnetic field around the cable or conductor. Then number 2 is inducing voltage in stator winding. Okay, how we induce voltage? First we have magnet, second we rotate this rotor, and third we have main stator here. This main stator consists of coil or winding here. Then this winding will receive and cut varying magnetic field which is generated by main rudder. Its primary function is to convert mechanical energy to electrical energy as the generator's rudder spins within it. It consists of winding and laminated iron sheet. Rudder has iron sheet too. What is this for? This is for core, to strengthen the magnetic field and strengthen the voltage. Okay, next, main stator here. It has many function. If I say here, first, receiving magnetic field. Number 2, generation of electrical output. Number 3, output regulation. Output regulation here, this main stator should be work together with AVR or automatic voltage regulator. Next, okay, number 4 function is power transmission. So once the AC power is generated in the main stator, it can be transmitted through electrical conductors to the load or connected to an electrical grid for distribution or utilization. This point is main stator work together with terminal, outgoing terminal. Next, we have a rotating rectifier. This part is convert 3-phase AC to DC as a supply to main rudder. Where is the 3-phase AC from? It is come from, what is it? I forget. Exciter rudder. The rotating rectifier in a brushless generator serves the crucial function of converting the alternating current generated in the exciter rudder into direct current for the generator's excitation system. This conversion is necessary for creating a stable magnetic field in the generator's main rudder to induce the required voltage in the stator winding. Next, we have exciter rudder. Exciter. This is exciter rudder. Okay, not a stator. Stator should be here. This is rudder. It is armature winding which cuts magnetic field of exciter stator and generate electricity. If in main generator, armature winding is main stator, in exciter generator, armature winding is exciter rudder. It has 6 cables that connected to rotating rectifier, but its output is 3-phase electricity. Why 6? It only 3-phase. Why 6 cable? Because 6 cable will connected to rotating rectifier here in U, V, and W. Next, we have exciter stator. Okay, part of exciter generator which convert DC supply from AVR to magnetic field. So DC supply become magnetic field. This magnetic field is needed in process of generating electricity in exciter rudder. The amount of voltage supply which come from AVR is varying based on the load. The higher the load, the higher the voltage which is given to exciter stator. Okay, this is important note. In self-excited generator, main stator has important role in initial start. It provides residual magnetism for first time generating electricity. There will be no voltage, or if maybe low voltage, okay, if residual magnetism is gone. Okay, so in brushless generator, self-excited, this exciter stator is very important, especially in initial start. If in PMG excited generator, initial start is helped by PMG, but this is different story if talking about self-excited generator. When generator stop working normally, there will be residual magnetism in exciter stator, which is used to initial generating electricity. Okay, continue to next part. We have terminal outgoing or outgoing terminal. I don't know which one is the correct from the English perfection. This is a part where electricity is taken to the system, so we cannot directly connect electricity to main stator, because it will be difficult to how do we say, I don't know, but we must use outgoing terminal to distribute electricity from main stator, because sometimes it has many cables that can be connected according to voltage needed. According to voltage need or needed, I don't know, sorry, my bad English. Sometimes for example here, 3-phase generator, the stator has 6 winding, not 3 but 6. 2 winding is line 1, 2 windings is line 2, and the rest is line 3. These 2 winding, okay, I give this red, yellow and black. If it's connected serially, then the voltage phase to neutral is 220 volt. If phase to phase, 380 volt. This is example in our country. In your country, maybe the amount is different. If I connect these two, what is it? Two winding parallelly here, so the voltage will be different with the serial star. This is serial star and this is parallel star. Because of this, because of main stator has many winding, so we should connect or work together with outgoing terminal to achieve the voltage that needed. Last is automatic voltage regulator. This part actually is not main part. This is if I do not use this, if I what is it, disconnect this from generator, I still can produce a voltage. How? I replace this with a battery or variable voltage. So what is the function of AVR? It plays a crucial role in maintaining the output voltage of an electrical generator. Okay, so it maintains output voltage. Every load we give to this generator, 0%, 10%, 50%, 70%, not percent, the voltage will remain same. For example, 3080. How we achieve that? We can use automatic voltage regulator. Why? This is automatically regulated. If I use battery or variable power supply, I can make this happen, but manually. So imagine how tired I am. I should wake up and check the voltage every time. So I can achieve this voltage same in every load. So if I do not want to be tired, I will use this AVR. Besides that, AVR also has a protective function against overload and under frequency. After this we will talk about working principle. Okay, here is the initial condition. In this initial condition, we have stay still rudder because engine is not started yet. And this is note, there is residual magnet in exciter stator here. It represented by blue arrow. This blue arrow is not what is it, line, or how do we say in English? I forget that word. Illustration, sorry. This is not the illustration line of magnet. This is represent energy flow. Okay, so from exciter stator to exciter rudder. Important component in generating electric initially, this is here, residual magnet. If this residual magnet gone, the electricity will not be generated. If you start the engine, run the engine until the fuel is gone, not gone, what is it, until the fuel tank is empty, there will be no electricity come from this generator. Next, after we start the engine, then when engine rotates, the rotor also rotates. There are three main components of electricity generation in exciter generator. First is magnetic field, represented by a residual magnet. Number two is conductor in a magnetic field. Where is it? Main, not main, exciter rudder. And then the intersection. Of course, if we rotate the rotor, the winding in rudder will cut the magnetic field which is produced in exciter stator. So if it's happened, then the intersection is completed. The three main components will be here. So what happened next? The electricity is generated. Three-phase AC voltage is generated in exciter rudder and rectified as power supply to main rudder. First, the output of rotor here is three-phase. Then, because it must flow through the rotating rectifier from AC, it becomes DC. The output from exciter rotor is used to excite the main rudder. So the magnetic field is generated like this. And then three main components in generating electricity is completed in main generator. Magnet from rotor, main rotor, and then conductor in main stator, and intersection because the rotor is rotate. Three-phase electricity is generated in main stator, go to terminal outgoing terminal, okay, and sensing transformer, terminal outgoing to the left and to top or yeah to transformer here. Okay, not all generator has sensing transformer. There are people call this potential transformer, or no, not potential transformer, isolation transformer, but I prefer say sensing transformer because this is used to give AVR sensing. This part is used to reduce amount of voltage that go to AVR. The output of transformer is used to be power supply and sensing for AVR. If in PMG, here is only sensing for AVR. The power supply is come from another side. But in self-excited generator, power supply and sensing comes from one terminal. Some brand need more than 6 volt AC to work properly. So if we measure from this terminal 6 to 7, if the measurement is more than 6 volt AC, then the AVR is ready to work. Okay. It's just like us, if we tell to do something, we have it first, or we must get some payment. If the food or payment is less than what it should be, then we cannot work properly. Next, we hear about electricity generated. AVR output is DC voltage, which is transferred to exciter stator to generate magnetism. Here is the note. AVR will directly give output after it receives power supply properly. Okay. Usually the output in normal condition, if the voltage is in nominal condition and no load, okay, then the voltage here is around 8 to 12 volt DC in one brand. Okay, in another brand maybe it could be different. Next, after that we have regulating the voltage. When exciter stator get voltage supply from AVR, magnetic field is become stronger. Before it gets some voltage, it only has tiny magnetism. After this winding get its food, then it will give stronger magnetic field. What is the effect of the magnetic field that becomes stronger? The effect is the higher the magnetism causes the output voltage of exciter rotor become increased. Okay, next, what will happen? Due to increase of current in main rotor, which is caused by increase of its supply voltage, the magnetism is become stronger. We have formula here. It explains magnetism is influenced by permeability, number of turn, coil strength, and current. If the current is higher, then the magnetism become higher too. Next, the output of main stator is also increased. Why? We have formula here. What is it? Electromagnetic field, EMF, equal NBA omega sin, what is it? Sin theta, I think. Sorry if I'm wrong, okay? It explains the amount of voltage is influenced by number of winding. It is fixed, okay? Winding here, it is not variable. Then magnetic strength. Before AVR give voltage, the magnetic strength is very poor. Not poor. What is it? Strong. Weak. Sorry. Sorry, I am too much watching anime, so I forget so many vocabulary. Before AVR gives voltage here, the magnetism in main rotor is weak, and the influencer here is coils area, angular speed, and angular position of the rotor. There are three, of course, yes, magnetic strength, angular speed, and position. Magnetic strength is by AVR output. Angular speed is from engine's RPM. And here we talk about magnetic strength. If the magnetic strength is get stronger, then the EMF here will be stronger. Okay, the output voltage also higher, increased. The voltage in secondary winding of transformer is also increased. Therefore, AVR receives different amount of sensing voltage. And AVR keeps increasing output voltage until it gets proper sensing voltage. It is based on setup value. If sensing voltage is more than setup value, AVR reduce its output voltage. Yeah, as I said before, normally it needs around 8 to 12 volt DC to achieve output 380 volt AC in no load condition. If we give load to this generator, the voltage will reduced. So AVR will read here from transformer. AVR will compare with the setup value. If the sensing is lower than setup value, then AVR will give or increase the output to exciter stator. First, 12 volt in no load. If we give load, example 10%, then AVR will give, for example, 20 volt, and so on. Okay, my friend, my brother and sister, I think for me, this video is this video is enough. Thank you for watching. I hope this video can be helpful for your study or for your work. Okay, I'm sorry for everything that come from my mouth or this visual if it is not comfortable for you. Okay, I need some suggestion from you all. Tell me what should I repair, or maybe there are so many wrong theory or wrong language. Please tell me. Okay, thank you for watching, and see you later. in another video.